Hi, in this video we shall see how to run simulation, functional simulation and check whether our schematic is proper or not. Uh, we will be looking at, there are many types of simulation. We will be actually looking at the transient simulation. So the word transient itself refers that you will be plotting a waveform, something with respect to time, right? So we all know how the inverter works, right? So let us consider, say, um, hmm, for example, you have your inverter like this. I will just choose pencil. So yeah, so in my input waveform is like this, for example. So my output waveform will be, it is like this, right? So it is just inverted. Wherever I will be giving 0, I will be getting 1, and wherever I will be giving 1, I will be getting 0. I can just give pulse as my input, and I can check the functionality of my inverter. So it is just one input, so I can just give one pulse, say for about 10 nanoseconds. Okay, the pulse width can be around 10 nanoseconds, and I can have around like 5 cycles of this. Okay, so 5 cycles means for how many times I need to, how many, for how much time I need to run, 10 nano into 5. So it will be 50 nanoseconds. Total simulation time is 50 nanoseconds, right? So we'll see that how it is going to, how we are going to do that. So to run simulations, what we need to do is go to launch and click on ADEL. So this ADEL form starts appearing. Here again you have your library name, cell name and the view name. Training videos, inverter 1 and schematics. So this is your ADEL window. ADE stands for Analog Design Environment. Okay, so first you need to choose the type of simulation you are doing. Choose the type of simulation you are doing. So here you have some options, as you can see. So choose analysis. Click on choose analysis. So by default it is there in transient, and I will be just giving my stop time as I had mentioned here. It is I need to run it for 50 nanoseconds. I will run it for 50 nanoseconds, right? And this is about the accuracy of the spice simulations that will be running behind. So conservative, moderate, liberal, generally I will be keeping moderate, so you can just click on anything. Conservative means, for example, so say you have some approximations need to be done, and say some 60, some answer is like 66.66666 something is coming at the back end. So if you keep it conservative, it will take like 6 digits. If you keep it moderate, if it will take only 4 digits. Okay. If you take it what is the other option, liberal, then it will consider only 2 digits. So your calculation is going to be affected by selecting one of these. Okay. So uh, you will be selecting any one of these. I will keep it moderate, and you need not worry about all the other things. You can just keep it default and click OK. So now it started appearing here. What are all the analysis that you will do? It will start appearing here, and I have enabled my transient analysis. Okay, and then it runs from 0 to 50 nanoseconds. Its start time is 0, stop time is 50 nano, and it is set to moderate. Okay, so now what outputs here? Like outputs in the sense, what are all the waveforms that I should be plotting it? That it is asking. So for that I need to mm, mention the pin names names or the net names. Net is what? This is my net. This is one net. This is the input net. This is the output net. So I need to mention the net names. So what I will do is I will just click on outputs, then then to be plotted, then select on design, and then select my input. It started appearing in green color, and then I will select, it started appearing in pink color. So this will be once you launch the waveform in the waveform viewer, you can easily observe that green color will be, your input will be in green color and output waveform will be in this pink color. And we have already done the we have already chose the analysis type, and we have also um, taken the signals that we need to plot. So the question is, if I run my simulation, does it plot? So, okay, so I will show it to you whether it plots or not. We'll see by running simulations. So it says there is some error. Okay, so we'll see what is that error. So if you see this type of error, okay, so GPD case and this type of error generally comes. You need to, what you need to do is click on model libraries, and you would have selected, you would have checked both GPDK045 and CDS FFmpt. This type of error you just need to remember. If some this kind of error comes, you need to check only the required PDK dot HCS. I am currently doing in 18 nanometer. I need to have only this CDS FFmpt. I need to uncheck this GPDK045. This is for 45 nanometer. Remember, if you are doing in 45 nanometer, you need to check this and uncheck this. But if you are doing in 18 nanometer FinFET, so you need to check this and uncheck the GPDK045 thing, and click on OK, and now rerun. So here it says, so what is this? And it says 1 e per minus 42 volts. So it is like almost zero, right? So nothing is happening. We haven't provided any input waveform only, and we are expecting the output waveform. Okay, so VDD VSS is also not connected. We haven't given anything. So it is just showing some waveform. Okay, so we'll minimize this waveform window, and now we shall give the inputs and input waveform and connect VDD to VDD pin to some voltage and VSS to ground 0 volt. So for that you need to click on stimuli. So here you have inputs. So VSS, uh, click on enable. Just remember this, many a times people tend to forget this enabling, and if you forget this VDD or enabling any of them, and simply if you are running, it is just like you have not provided that signal if you haven't enabled it. So then function should be of DC type, and voltage is how much? 0 volt, and click apply. Now you can see here VSS is now connected to 0 volt. Similarly, select VDD, click enabled, go to click on DC and DC voltage, click for this technology VDD should be 0.8 volt. Just remember this, for 18 nanometer technology, VDD should be 0.8 volt. Click on apply. So now you can see here it is enabled on. If I have done this and click, I would apply, so it says it is off. VDD is not connected, unconnected it is. If I click enable and click apply, now it is enabled 0.8 volt. Now I need to give some waveform for Vin. Click enabled, then click on function, and then click on pulse. So you have pulse, right? So this is you will be knowing pulse. What do you mean? So it has two voltages. So let us consider you have this is your pulse, this is your voltage 1 and this is your voltage 2. Okay, so you have two voltages. So what it will be, so one of the voltage will be 0 and one will be zero point 0.8, right? So that you should need to give here. So it's 0 and it is zero point 0.8, and then period is we shall give 10 nanoseconds because we will be running over 50 nano and we require uh, period 5 cycles. So 10 nanoseconds is my period, and delay time is for example you have your um, x-axis and y-axis here. So my pulse is, say, it is starting from here. Okay, and I have one more pulse which is actually starting from here. So I can say that my pulse 2 is, say, let us say this is 2 nanoseconds. So now I say that my second pulse, this is 1, this is 2. So I can say that my second pulse is delayed as compared to the first pulse by 2 nanoseconds. So by default, this is the thing it is considered, and if I give any delay here, it will be considered. So it will start after that delay. Okay, so as of now I am not giving any delay. Then we have rise time and fall time. So you know that, right? We are using a pulse, those are practical. Practically we don't having the steep increase and steep decrease waveform like this. Okay, I'll just delete this. So here you have, you won't be having steep rise and steep decrease, right? So your pulse will be, practical pulse will be what you have. um, there are some rise time, it will be slant like this, then it will be reaching your VDD, and then you have some fall time, then it will be reaching your 0 volt and again increase. So this is your rise time, and similarly this is your fall time, right? So that it is asking. So generally it is given as 100 picoseconds or 50 picoseconds. I will give 100 pico. Okay, P stands for pico, N stands for nano. Okay, then pulse width. So pulse width is, say, for example, this is your one cycle, and this is there for 10 nano, and this is your pulse width, which should be like 50% duty cycle. If I say it is 5 nano, or you can keep it 6 nano, 2 nano. I am just using 50% duty cycle, so I will keep it 5 nano as of now, and then click OK. So now I will run. So it says it is done. We'll open the waveform viewer now. So we have some waveforms, but it is, everything is overlapped. So to make them like separate, what we have to do is click on this split all strips. So you have your V in here and you have your V out. So you have basically 1, 2, 3, 4, 5 cycles. 1, 2, 3, 4, 5 cycles you have, right? So it is exactly inverting, and you can just zoom in to one particular waveform, and as I had say, This is your rise time, and your output will be falling at that time. And similarly, you can observe your fall time here. It will be 100 picoseconds. So you can see here 5.1 nano, and here it is 5.2 nano. So fall time is 100 picoseconds, and your output is rising, right? So you can just zoom in like that, and if you want to zoom in horizontally like this, press and hold shift, press and hold control and scroll your mouse button. So that will help you zoom in vertically like this. And if you press and hold shift, and if you scroll up and scroll down, you can zoom in and zoom out like this. So this is your waveform. So this is you are giving 10101010. What if I wanted to give my input as 110101, like that, some different combination? So now we'll see how to do that. So again, go to stimuli. Now VSS VDD are DC inputs only. We did not do any change over there. We shall be doing some changes in VIN. So instead of pulse function, we'll give bit function. Okay. So for bit, what is the one value? One value is our VDD 0.8, and zero value is what? 0 volt. And rise time is, again, I will give this time 50 picoseconds, and fall time I can give 50 pico, and period of bit I will give 10 nano, and now pattern parameter data. So I will be running for 50 nano seconds, and period is how much? 10 nano. So I can give here 5 bits. Okay, so 11010, or I can give something like 01101, like this. I will give 01101 and click OK, and then run again. Maximize the window, split all the waveforms 0 1 1 0 1. So I will be getting 1 0 0 1 0. So it is perfect, right? So it is proper. You are getting, you are able to see in the waveform. So my inverter schematic is proper. My waveforms are coming properly as expected. This ensures that my schematic is proper. So now I have done all these simulations, and I may require to see this simulation and again. But every time I need not do this, all these settings again. Instead of doing all those things, I can save the simulation result or these ADL settings like this. I will show how now. So what I will be doing is I will click on this floppy disk icon, save state, and then click on cell view, and then give the name. This is transient analysis, right? So I will be saving it as trans. Okay, if you want to write some description like functional simulation of inverter, or what is the VDD VSS value that you have given, or what is the input data type that you have given, you can write all the descriptions. If you want, you can write it here and click OK, and then close it. So if you go to your library, so here you have that trans state. It is one more view. Okay, so trans is your transient analysis that you have created, that view has been created using ADEL, right? So how do you load that when you open your schematic? So you open your schematic like this, launch ADEL, and then click load state. Then click on cell view, and here you will be having trans, and then click on OK. So as you can see, I need not do that all those things again. I have all my transient analysis settings saved and reloaded now. I have all the waveforms that I will be plotting V in V out again here, and all the settings are saved. You can see everything is proper. Stimuli, if I check stimuli again, it is also proper. Everything has been saved, was saved, and now it has been reloaded. Now I can just run this, split it and maximize it, and just see the waveform for yourself and check whether you have got the waveform as expected or not. That will ensure whether your schematic is proper or not. You can just close this, and this is how you create a state using ADL and save it and load it whenever you require. So once you are done with that, you can just close the ADL, and that's all for this video. Thank you.